derivatives. Because from y'all's last quiz, I feel like y'all can do well when it's just like take the derivative of this. But it's like when it's asked you to apply it, or we have to like interpret what a question is asking, that we tend to struggle. So we're gonna review some of that. So it says use the following function to find the following. So part A asks us to find the average rate of change from 1 to 8. So what is average rate of change? The slope of the secant line. So it's just our slope formula, right? So what is our slope formula? F of B minus F of A divided by B minus A. But as long as you get y minus y divided by x minus x, okay, as long as you plug it in correctly, it doesn't matter that you write out the formula right or not, okay? That part's not that big a deal. Okay, but also remember, instead of saying find the average rate of change, what could it also ask you to do instead? Remember that our slope of the secant line is also an what for our derivative? Is an estimation. So it could also say estimate the instantaneous rate of change. Now remember, even if it says estimate, it does not just mean guess. Okay, it means you have to use a particular formula to get an estimation, which in this case is your slope formula. So what is our B value? 8. What is our A value? Okay. So then I have 8 minus 1 on bottom. So what do we need to find? F of 8 and F of 1. Okay. So if we plug in F of 8, I'm just going over to the side. So 8 squared gives us 64. What is the cube root of 64? 4. Okay. 2 times 8 gives us 16 minus 64. What do we get there? Negative 48 times 4 gives us negative 192. Okay. And then what about F of 1? This is just going to be 1 times 2 minus 1, which is also 1, so we get 1. We like that one a little bit more. Yep. Okay, so we get negative 192 minus 1 divided by 7. So we get negative 193 divided by 7. And now we're variance. I'm pretty sure it doesn't go into it either. Yeah. So again, that would be our approximation or estimation of our instantaneous rate of change, or it's also our average rate of change. Now, on part B, what do they ask us for? Yeah, on that one, they actually ask us for the derivative. Okay. So, what do we need to do first? I want to plug 4 into the derivative. What do I have to have first? The derivative, yeah. So we could do this one of 2 ways. One, we could rewrite this as x to the 2/3, yes? And then distribute that, and then just use our power rule. However, remember we learned our product rule last week, so we could also go ahead and try and practice using our power rule. Yes?
Yes.
Alright. So we do want to go ahead and rewrite it even with our power rule as x to the 2/3, because that's going to be our first. And then my parentheses is going to be our second. This is part B. So then remind me, our product rule tells us I take the derivative of the yes. So I take the derivative of the first one, yes. And so what would we get?
2/3 x minus
To the
negative 1/3.
Okay, and then we leave our second one alone. Yes, so we have 2x minus x squared. And then remember that we add, and we're going to take the derivative this time of our second one. We'll leave our first one alone. So I get 2 minus 2x. Yes? If we went ahead and cleaned that up just a little bit, we would get 2 times 2x minus x squared divided by the cubed root of x plus x to the 2/3 times 2 minus 2x. You could also write that as the cubed root of x squared. Yes? And then what do they ask us to do with that? Plug in 4. So, 2 times 4 gives us 8 minus 16. Times 2 is negative 16. Divided by the cubed root of 4. That's fun. Plus, we have the cubed root of 16. Yes, because that would be 4 squared. And then this would be 2 times 4 is 8. So 2 minus 8 would give us negative 6. Yes? We're looking for that. So if this was a non-calculator active question, that would be my answer. Because we don't know what the cubed root of 4 or the cubed root of 16 is. However, if it was a calculator active portion, we would plug that into our calculator. And what do we get if we plug it into our calculator? So someone plug it into their calculator for me. What do we get? It should be negative.
Is better?
Yes.
I don't really understand how we got 2 times 2x minus x in this section all over the cube root of x.
So on my first one, we have x to the negative 1/3.
Yeah.
A negative puts it in my denominator.
Yep.
And a 1/3 is the same thing as cube root.
Oh, shoot.
So I was just rewriting it to simplify. Because remember that, for the most part, like if this was a free response question and it just asked you to take the derivative, you could have left it there. But for the most part, if it's just saying take the derivative, that's not going to be a free response. That would be a multiple choice question. And usually, they're going to simplify at least a little bit. You know what I mean? So you need to make sure you know, this is actually a fraction. That's where it goes. That sort of thing. Yes.
I got like it.
Let's say x to the negative 1/3 is 1 over x cubed.
The cubed root of x.
Where's the 3?
Oh, there you go.
That's why I was wondering.
Correct. You dropped it. So change what you're plugging into your calculator.
It's a lie. I'm pretty sure it just died.
So plug it into our calculator.
I got negative 5.036.
I don't agree.
Go 9, 18, 20, 28.
negative what?
18.47.
For rounded 3 decimals. 9. That's what I got. Which, if we had plugged in this one, what do we get here? On our first answer. What's negative 193 divided by 7 approximately? 20, negative 20 something?
-27.57.
So, I mean, like, not super close, but again, this is just an estimation, and this is a very large interval. Like, if we wanted to estimate it very, very well, we would have gone from, like, 3 to 5 or something like that. But it's still, both of them are negative, so that's good, and it's not like we got 200 on this one and, like, 2 on that one. So, they're still within the realm of, like, okay, that makes sense. Alright, do we have any questions on any of the stuff that we did up there? Okay, so looking at another one. This time we have a quotient. So what are we probably going to use? Our quotient rule. Alright, but does this one ask us to take the derivative?
No,
Does it?
vertical.
When we see tangent lines, what should we think of? The derivative. Okay. So if I have a vertical tangent line, what is the slope of a vertical line? Undefined. So we're looking on part A, where the slope is undefined. But reminds me, what is the slope of a tangent line? The slope of the tangent line is the derivative, yes? And when will I have something that's undefined? Yes, so we're going to take our derivative, and then we're going to figure out where is our derivative have a 0 and not a 1. Now, on the second part, again, we're looking at the tangent lines, okay? This time it asks me for horizontal tangent lines. What is our slope for a horizontal line? Okay, so now we're going to look for where the top is 0 instead. Yes? So this is a good example of one where you are technically taking the derivative, but it doesn't actually ask you to take the derivative. So you have to know that a tangent line, okay, means that I'm taking the derivative, and that if it's a vertical tangent line, the slope is undefined. And if it's a horizontal tangent line, the slope is 0. And you will see these a lot when we are using our quotient rule. Yes, because if I use my quotient rule, I'm probably going to end up with a fraction. So I have a top and a bottom that we can set equal to 0. Yes? Are we all okay with that? So let's go ahead and take our derivative. So remember that we have the bottom times the derivative of the top. Well, remember that we could rewrite this as 4x to the 1/2. Yes? So what is the derivative of our top? To the negative 1/2 plus do I add? So I have low d high minus, okay, remember that our quotient rule has subtraction. So low d high minus high d low, so 2x all over quantity squared. Yeah. Now, remember that we are wanting to set the top and the bottom equal to 0. Is that a very nice top right now? No. So we do want to go through, and this is a case where we do have to simplify. Okay, not because we have to make it look nice, but because it's going to be really hard to try and solve that. And eventually, you're going to have to simplify it in order to be able to set it equal to stuff. Okay, so if I have a negative 1/2, what does that become? times the 2 becomes a 8x square root of x. Yes? And again, remember, we're trying to set our top and our bottom equal to 0. But what's our problem right now? Well, it can, but like, how many bottoms do we have right now? We have 2, right? Because we have a fraction within a fraction. So again, we need to clean this up a little bit. Are you with me?
Yes.
But notice it is going to be 9. Okay. If I multiply this second one by a square root of x, what is square root of x times square root of x? X. And then I already have an 8x, so I just end up with 8x squared. Agree? All over the square root of x. All over x squared minus 2 quantity squared. Yes? So then how would I change that one last time so that I just have one big fraction? Well, first off, we could, let's go ahead and, if I distribute, that 2, right, I would have 2x squared minus 8x squared, so that gives me negative 6x squared minus 4. Are we okay with that? Up top? Yes?
Yes.
Okay. Then I still have a square root of x on bottom. But then remember, I would multiply by the reciprocal. So I would get 1 divided by x squared minus 2 quantity squared. So it is still going to be on our bottom. It's just going to be on the bottom with x squared root of x now. Okay, up until that point. So really, at the end of the day, alright, it didn't look super great to start with, but it simplified out to be fairly straightforward. Yes? But remember, what are we trying to do? For part 8. Set which part equal to 0? The bottom equal to 0. Okay? But, lucky for us, that's already in factored form. Yeah? So where is the square root of x going to equal 0? 0. Okay. And then if I set our second one equal to 0, we would take the square root of both sides, so we get plus or minus 0. Then we would add 2, and then take the square root, so we get plus or minus the square root of 2.
Wait, say that again? So what did you have to, what was the first step?
Take square root of both sides.
Square root
But
of
the
0.
square root of 0 is still just 0.
And that's why it's, oh wait, never mind. Square root of 2, that's why it's plus or minus, right?
Yes, technically I had plus or minus 0, but plus or minus 0 is still 0. Yeah, so. Alright, okay with that. So how many places do we have vertical tangents? 3. So on our graph, whatever that graph looked like, there should be 3 spots where it kind of like goes up really steep to where you have a vertical tangent at that spot. Okay? Now for part B, what do we want to do?
So the top equals 0.
Alright, so I have negative 6x squared minus 4 equals 0. So what do? Add 4 divided by negative 6. So we would get negative 2/3. Then what do? Can I?
No.
Why not? Agreed. And can I ever have an x squared equaling a negative? No. So there's just none. So there are no spots that have a horizontal tangent. And that'll happen sometimes. You alright?
Yeah.
That'd be like a imaginary number?
Yes, but for the purposes of the question, like whenever it asks you like where the vertical or horizontal tangent lines are, remember that we're talking about an XY graph, so we're only talking about real numbers.
Okay.
But yes, you would get an imaginary number there.
sure where I went wrong with here, but I ended up having like a -6, or not a -6, a +6. I just put a negative. Never mind, we're good. Never
Because
mind.
this is minus the squared. So
Oh,
like this would be 2x squared minus the
Oh,
right,
yeah,
so I
yeah.
get negative.
I
And
didn't.
this should be a 4.
Oh wait, I can wrote it down here.
Yeah, but you just like flipped it all of a sudden. So 2 times 2 gives me 4, right?
That's right. Thank you.
Other questions? So again, really, after this first step, where I took the derivative, that was the calculus part, yes? Everything after that was just extended algebra, right? This was all just simplifying fractions. This was all just setting the top and the bottom equal to 0 and solving. And want to know, like 90% of the time, people make the mistake in this stuff, not in that calculus stuff, okay? So that's why we have to be careful about.
Excuse me, can we see Connor Harris in the counseling office for a bit, please?
Okay. Yes, so we just have to be careful about our algebra steps and making sure that we're simplifying correctly. Alright, continuing on. So, these ones, we're looking at higher order derivatives. You don't have to write all this down. Basically, it's just saying, notice, on my first derivative, I have a one, like, tick or prime. Okay, or we can write it dy dx, or d dx, okay? You're not going to see this one very often. That's a very old school way of writing it, but it's there. My second derivative, I'm going to have 2 primes, or f double prime of x, or d2y over dx squared, okay? On my third, I'm going to have 3 tick marks, or with a 3. Once we get to the fourth, we kind of stop doing tick marks because they kind of all start blending together. We just start writing a 4, okay? And we kind of talked about this when we talked about acceleration. Basically, I'm just taking the derivative of the derivative that we got. Yes?
Yes.
So, like, my derivative of velocity is acceleration. But this is true with any type of polynomial that we have. I can always take the derivative of something. Yes? You okay with that? And that's all that taking the second or third derivative means, is to take the derivative of whatever you got. But like I said, most of the time, let's look at some application problems of this. So it says, because the moon has no atmosphere, a falling object on the moon encounters no air resistance. In 1971, astronaut David Scott demonstrated that a feather and a hammer fall at the same rate on the moon. The position function for each of these falling objects